All right, let's talk about the secret sauce behind artificial intelligence. We're going to dive into the evolution of AI optimizers, which is really the story of how machines learn to, well, learn better.
So, you hear about AI learning all the time, right? But what does that actually mean? How does it happen? It's not magic, I promise. It's really a process of trial and error, a journey of just getting a little bit better over and over again. And the thing that guides that whole journey, that's what we call an optimizer.
To make this super clear, we're going to use an analogy that'll stick with us. Imagine an optimizer is like the strategy for a hiker. This hiker is trying to find the absolute lowest point in a huge foggy valley. They can't see the bottom, right? The fog is too thick. So the optimizer is their rule book. It tells them, okay, which way should I step next and how big should that step be? That's it. That's the game.
Okay, so let's start our trek at the very beginning with the simplest strategy out there, an optimizer called SGD.
So this first one, SGD, which stands for Stochastic Gradient Descent, it's about as basic as you can get. Our hiker literally just looks down at their feet, finds which way the ground slopes down, that's the gradient, and takes one step in that direction. And here's the key. That step is always the same size. We call that the learning rate. Doesn't matter if it's a steep cliff or a gentle slope, the step size is identical. It's simple for sure, but maybe a little too simple.
And yeah, that simplicity, it causes some major headaches. For one, it's slow. But even worse, our poor hiker can get stuck really easily. Imagine they step into a tiny little dip in the ground or onto a flat spot. They look around, and from their perspective, there's no downhill anymore. So they just stop. They think they're at the bottom, but the real valley floor is miles away. The whole learning process just stalls out. Obviously, we needed a much better plan.
This brings us to the first big upgrade. How do you stop getting stuck? You add some speed with something called momentum.
And the solution was pretty clever. SGD with momentum, or SGDM for short. Think about it like this. Instead of our hiker just taking one single step and then stopping to look around again, now they get a running start. As long as they're heading downhill, they start to build up speed.
Yeah, that's the key idea right there. The optimizer now kind of remembers the direction it was just going, and that memory, that momentum, is what helps it just blast right through those little flat spots or even tiny uphills without getting tricked and stopping.
So what's the result? A way more efficient trip down the mountain. That momentum means a smoother, faster descent into the valley. Our hiker isn't just taking one clunky step at a time anymore. They're practically gliding towards the bottom. But what happens if the terrain itself is the problem? This question led to a totally new way of thinking about this, which we call the adaptive approach. It asks a simple question. What if our hiker could be smarter? What if they could change how big their steps are based on the path they're on? And that's the core idea of an adaptive learning rate. So instead of that one-size-fits-all step for the whole journey, the optimizer can now adjust its step size for every single direction. Think about it. If the path ahead is steep and smooth, our hiker can take these huge, confident leaps forward. But if they hit a patch of loose, rocky ground, they'll shorten their stride, taking smaller, more careful steps. It adapts.
Okay, so the first crack at this was an optimizer called Adigrad. And it was actually pretty good in specific situations. You know, like when you're crossing a giant flat field with only one or two clear paths down. But it had a fatal flaw. Adigrad was way too cautious. Over time, it would just keep shrinking the hiker's steps, smaller and smaller and smaller, until they were barely moving at all, even if they were nowhere near the bottom yet.
So that's not going to work. We needed a fix. And that fix has a name, RMS Prop.
So how does RMS Prop solve this? Well, it also uses an adaptive step size, but it has this one really clever trick up its sleeve. Instead of just looking at the slope right at its feet, it uses a moving average of how steep the terrain has been lately. It's like it has a better memory. And this one change prevents it from getting overly cautious too fast. It totally fixes Adigrad's big problem and lets our hiker keep on moving towards that goal.
Okay, let's pause and recap. We've got momentum, which is all about speed and bulldozing through obstacles. And we've got adaptive rates, which are about being clever and adjusting to the terrain. So what if you could have both? Well, you can. And that brings us to what's pretty much the modern standard, ADAM.
The recipe for ADAM is actually super intuitive once you see the pieces. Step 1, you take the power of momentum, so our hiker remembers where they're going and keeps up their speed. Step 2, you add the smarts of an adaptive learning rate, so they can take big or small steps depending on what's ahead.
It's not a brand new idea, it's just a brilliant combination of the best ideas we've already seen.
And really, that's what Atom is. It is the best of both worlds. You get the raw speed and the power to push through rough patches from Momentum, and you get the intelligent, careful steps of an adaptive optimizer all rolled into one.
And that's why Atom is the go-to choice for almost everyone in deep learning these days. The biggest reason? It just works, right out of the box, for a huge range of problems. You don't have to spend ages tweaking it, it's tough, it's efficient, and like we said, it just combines the best tricks we've learned along the way.
So let's just quickly trace that evolutionary path one more time. We started with the super simple one-step-at-a-time SGD. Then we gave it a boost with Momentum to make it faster and tougher. On a totally different branch of the family tree, we got smarter with adaptive learning rates, leading to RMS prop. And finally, Atom came along and basically merged those two branches, combining the speed of Momentum with the smarts of adaptive rates to give us the powerful tool most people use today.
Which brings us to one last thought. Atom is the king of the hill right now. It's the standard for today's AI. But this field is always evolving. Nothing stays on top forever. So it makes you wonder, right? What's the next big problem that a new optimizer will have to solve? What kind of crazy new terrain is our hiker going to have to figure out how to navigate next?